Welcome back to this chapter of our physics syllabus. We are looking at DC circuits and especially circuit rules for this chapter, and we are moving on to part 2 in this video lesson. In this video lesson, we're going to look at the third series circuit rule, and we're going to look at some examples where we use the circuit rules in our calculation. Just to give you a bit of recap, these are the circuit rules that you learned. There are 3 overall. Rule number 1 is for the current, and the current is basically the same everywhere on the circuit. And rule number 2 is for the voltage, and in this case, the sum of all the potential difference or the voltages in each of the component should be equal back to the sum of the value for the EMF. Now for rule number 3 is something that we'll look at in this video lesson. What is rule number 3? Rule number 3 is basically a rule for the resistance. This is something that we looked at in the previous chapter as well, so I can quickly go through this one. So if you have resistors in series, if you want to find the total resistance, basically all you have to do is just to add them up all together, and that will give you the total resistance, or also known as its effective resistance. Now we have all 3 rules ready. We can use these rules when we are trying to solve problems involving circuit. So let's do that. Example 1, you have a circuit with 1 cell and 3 resistors, and then you have 2 emitters there. Everything is in series. Therefore, we can use series circuit rules for this circuit. A. State the value of the electromotive force of the dry cell. So what is the EMF of the dry cell? Let's quickly look at our diagram. The EMF is 6 volts. Very easy. B. What is the combined resistance of the 3 resistors? So we have 1, 2, 3 resistors here. We want to find the total resistance. All we have to do is add them all up together. R1 is equal to R2 plus R3. R1 is 2, R3 is 3, R3 is 6, and that is equal to 11 ohm. C. What is the current recorded on emitter A1? Okay, so we know the total resistance, let me just write down here, is 11 ohm, and the EMF is 6 volts. How can we find the current in this circuit? We can find that by using this formula, which is a formula that we used in the previous chapter, and it's the formula for resistance. We know what the total resistance is, we know what the total voltage is, therefore we can figure out what the current flowing through the circuit is. Because we want to find the current that is flowing in all of the circuit, we have to use the total resistance. So the total resistance is 11. The total voltage is 6. This is the EMF, okay? And then the current is I. So if you rearrange that, you will get 6 divided by 11, and that is equal to 0.545. Don't forget the unit, which is amps. So at ammeter A1, we have a current of 0.545 amps. What about in emitter A2? What's the current here? Remember, the first rule of the series circuit is that the current is the same at every point. So for emitter A2, even without calculating, we know that the current is basically just the same. D. Calculate the potential difference across the 2 ohm resistors. Let's write down all the values that we know currently because that will help us in our calculation. Okay, and we want to find the potential difference across the 2 ohm resistor. In this case, you just have to use this formula here. R is equal to V over I. Rearrange this to make V the subject of the formula. So V is equal to IR. So what's the current flowing through the 2 ohm resistor? It's basically the same current as at every other point on the circuit, which is 0.545. What is the resistance of this resistor? It's 2. Therefore, that will give you 1.09 volts for the 2 ohm resistor. What about for the 3 ohm resistor? This is basically the same working but for a different resistor. So it's the same current. The resistance is 3 and that is equal to 1.635 volts. And we'll do the same for the 6 ohm resistor, and that's the answer for these three. Now you can stop there, but if you want to check whether the answer is correct, what you can do is you can use the second circuit rule, which is for the voltage. We know that the voltage across the 2 ohm is 1.09 volts. Across the 3 ohm is 1.635 volts, and across the 6 ohm is 3.27 volts. And according to the second series circuit rule, if you add all the potential difference together, that will give you back the EMF. And so if you do that, this one is plus this one plus this one, it should equal back to the EMF, that one there. And that is true in this case, and therefore you can confidently say you got the right answer. Right, so to summarize, in this video lesson, we looked at the third circuit rule, which is the rule for the resistance. And it says that if you have more than one resistor, what you can do is you can add them up together, and that will give you the total resistance. These are the three circuit rules. Make sure you remember them when you are doing series circuit rule calculations or problems. For part 3, which is the next video lesson, we're going to look at parallel circuit rules.